A bullet of mass 20 grams is horizontally fired with a velocity of 150 meter per second from a pistol of mass 2 kg. What is the recoil velocity of the piston? Not piston, sorry, pistol. So to solve such a problem, we have to make use of law of conservation of momentum. So to talk about law of conservation of momentum, we need to have before and after scenarios. So what is the before scenario and what is the after scenario? What do you think? Is it before explosion, after explosion? It's something like that. Before sunset, after sunset? What is it? It is before firing and we are comparing it with after firing. By comparing the momentum of these two scenarios, because this two scenario talks about the same system, we can equate them and find the velocity, right? It's very convenient. So before firing, what happens to the rifle and the bullet? Nothing happens. It's stationary, is it not? So I have the rifle and the bullet. They are stationary. They are not moving. So here the velocity of the gun and the bullet is 0 meter per second. Mass of the bullet and mass of the gun is 20 grams. We need to convert this to kg and this is 2 kg. Right? And after collision, what happens? We have the gun pushing the bullet. That is your action. And what is the reaction? Reaction is the gun gets pushed back. So this will move to the left and this will move to the right. So can you see that I'm representing them with different arrows? This is longer and this is shorter. You know why, right? The velocity will not be the same. So this is the velocity of the bullet and this is the final velocity of the gun. So this bullet is moving at a speed of 150 meter per second. And here the recoil, that is the pushback that is on the gun. It is VG. We don't know how much is that. We need to figure it out. Okay, so this is your entire picture. So let's convert. First thing is we need to convert MB. MB is 20 grams. So 1 gram has 1 by 1000 kg. So this would be equal to 2 by 1000 kg. So this is 2 by 100 kg basically. So you guys can write this as 2 by 100. Don't convert further. This is good enough. Now we need to work out. So this is your working. So we need to state that as per law of conservation of momentum, the momentum of the system before firing, the momentum before firing is equal to momentum after firing. Does that make sense? So what is the momentum over here? It's basically 0, but yes, we need to write. There are two things that we are considering: the gun's momentum, so the mass of the gun, plus UBMB is equal to VGMG plus VBMG. And now we need to substitute things. So this is 0 and 0, so this is 0, right? And on the right hand side we have VG that needs to be found. This is 2 kg plus this is 150 and this is 2 by 100. Please don't do any mistake while substituting. Don't take it as 20, then the whole thing will be wrong. So this is 30 by 10, so this is basically 3, right? I made a mistake in the last video, so I'm continuing it over here with this set of values. So on the left hand side we had a 0 and on the right hand side we had 2 VG and this was 30 by 10. I took this as 30, not 3, so that was my mistake. Now I'm taking it as 3 and I'll continue. So 0 is equal to 2 VG plus 3. So next is minus 3, minus 3. So this and this get cancelled. So we have minus 3 is equal to 2 VG. And then we'll divide with 2 both the sides. So Vg is equal to minus 1.5 meter per second. So the recoil velocity of the gun is 1.5 meter per second in the direction opposite to that of the bullet. Okay, so this is your answer. So first part you guys can go back and pause and write down. This is the second half. Oh yeah, by the way, this negative value indicates that it is opposite to the direction of the bullet, because the direction of the bullet I'm taking it as positive. Obviously the recoil velocity would be opposite to the direction of the bullet, is it not? It will push back, the bullet will push the gun back. Okay, so that is your negative value.